Welcome. In this session, we'll learn, we'll solve some examples based on this phasor analysis. Let's start with a simple RL circuit. Suppose we have a very simple RL circuit, R and L connected in series to voltage. So the circuit. So let's suppose the voltage here is V of t is 10 cosine of, let me write it here. So voltage is simply 10 cosine of 100t volts, and resistance is 3 ohm, and inductance is, let's suppose, 1/25 henries. And we need to find I of t flowing in the circuit, and also we need to compute the impedance of this circuit. Suppose we also need to find Z of this circuit and current flowing in this circuit. Okay, so what we do in phasor analysis, we draw the phasor equivalent of this circuit. So how many elements do we have? We have 3 elements: voltage source, resistor, and inductor. What we'll do, we'll write these 3 elements in phasor domain. Voltage source is 10 cosine 100t, so we'll convert this in the phasor form. We'll write the phasor equivalent of resistor, and we'll write the phasor equivalent of this. Okay, now we'll draw the phasor equivalent of this. So the phasor equivalent of this is, what happens to a resistor in phasor domain? R is replaced by simply R, and inductor is replaced by J omega L. J omega L, and voltage source is replaced by simply 10. Phasor equivalent of this is phase is 0. So 10 at an angle of 0 volts. Okay. Now what is J omega L here? And J omega here is, you can check it, 100. And L is 1/25. So this will be equal to 100 divided by 25 is 4G. Okay, so this is the impedance offered by this inductor, and impedance offered by resistor is 3. Okay, now current I will write as I phasor. All right, and remember, as we learned in the previous section, all the techniques that are valid for resistor are valid for impedance. Okay, all the techniques, rules, laws that are valid for resistances are also valid for impedances. Okay, so what we'll do, we'll apply KVL in this loop in order to obtain the I phasor current. Okay, so let's write the KVL for this. So we start from this point. So we encounter first minus 10 at an angle of 0, plus, then we encounter resistor. Resistor impedance is 3 multiplied by current. This is the voltage drop in resistor, plus the voltage drop in inductor will be 4J times I. What's 4J? 4J is the impedance. This will be equal to 0. Sum of voltage drops around a loop is equal to 0. Now to find I, we'll simply manipulate this equation. So we'll write 3 plus 4J. We'll take I outside, and this will be equal to 10 at an angle of 0. Now we can write I as 10 at an angle of 0 divided by 3 plus 4J. So what is I equal to? I is simply equal to division of 2 complex numbers. One is given in polar form, another is given in rectangle form. Let's convert both these complex numbers into polar form. Okay, so we'll convert 3 plus 4J, we'll write in this polar form. Now polar representative of this will be under root of 3 square plus 4 square, that is the magnitude. That will be equal to 5 at an angle of that 10 inverse 4/3. 4/3 is 53.1 Okay, please check this. Okay, this will be equal to, so how do we divide two complex numbers? We divide the magnitudes and subtract their phases. So what is 10 divided by 5? That's equal to 2 at an angle of minus 53.13 degrees. So this is the I phasor. This is in phasor form. So to find I of t, we know how to convert F phasor current to time domain form. I of t simply will be equal to amplitude is 2 cosine. Now the frequency is 100 here, so 100 t minus 53.13 degrees ampere. So this is the phase of this. So this is the current flowing in the series circuit. Now in order to find impedance, what we'll do, we'll divide the V phasor by I phasor. What is the voltage of source? So impedance Z will be simply equal to V phasor and divided by I phasor. What's V phasor equal to? 10 at an angle of 0 degree divided by I phasor. I phasor is simply 2 at an angle of minus 53.3 degrees. So this will be equal to 10 again divided by 2 at an angle of 0 plus 53.13. Why plus? Because when we subtract 0 with minus this, it will become plus. Okay. So this will be 5 at an angle of 53.13. So this is the impedance in polar form. We can also write it in rectangular form. So we can convert this in rectangular form like this. Okay, 5 cosine 53.1 is 3 plus j 5 sine 53 is 4. So this is the impedance offered by this network to the source. Okay, this is the impedance and the unit will be ohms. Okay, now we already know impedance of the circuit is because these elements are connected in series, so impedances will simply add as impedances follow all the rules of resistance. So it will be 3 plus 4j. Impedance offered by resistor is 3, impedance offered by inductor is 4j. Okay, so in general you will remember if a resistor and inductor are connected in series, if R and L are connected in series, then the impedance offered by this network will be simply series RL circuit will be R plus J omega L. What's omega? Omega is the frequency of source. So omega is the frequency of source. This is how we find the impedance of this. Okay. Now what I want you to do is draw the phasor diagram of voltage in this network. Okay, please try that. Take I as reference because this is a series circuit and draw the phasor diagram of this voltage in this circuit. Okay. All right, let me end this session here.